Hello students, this is lesson U3A05b. By the end of the lesson, you should be able to say I can apply concepts of rigid motions with concepts of triangle congruence. So if you recall what rigid motions are transformations that preserve length and angle measures. So since we're on the topic of proving triangles congruent to one another and having the understanding that if two triangles are indeed congruent, then all the corresponding parts of congruent triangles must be congruent. This is inherently a concept of rigid motion, right? So because of the very fact that rigid motions preserve side length and angles. So if an object were to be transformed, that object will have all the lengths be the same exact length, have all the corresponding lengths be the same exact length, and have all the corresponding angles be the same angle measures. So therefore, the concept of rigid motions and triangle congruence go hand in hand. They are actually the same ideas, okay, just worded differently. So let's take a look at how or why that is, just a little closely with some examples. So let's take a look. So right now, I went a little ahead of myself there. All right, so I have the situation where I have triangle ABC and triangle DEF. What I need to do is I want to prove that triangle ABC is congruent to triangle DEF. And what I want to do with this is I want to then show or explain how a sequence of rigid motions will bring triangle ABC to triangle DEF. So because this thing is graphed on a coordinate grid, we're going to approach this through through the use of some analytic geometry, some coordinate geometry. All right. So we're going to approach this by finding out what the side length of AB is, and looking at this, looks like side length AB is equal to 1. We're going to then find out what side length BC is, and by using Pythagorean theorem, we can recognize that BC will be square root of 5. Side length AC will have a length of 2, because I can just count. It's a vertical line there. Similarly, I can find out what is the side length DE, which is 1. Side length EF is square root of 5. And finally, side length FD has a length of 2. So these two triangles are actually going to be congruent based on side, side, side. So these two triangles are in fact congruent. We've accomplished the first task here. We've proven that the two triangles are congruent to one another. The second thing that we have to do is we need to describe a sequence of rigid motions. So upon inspection here, I notice that ABC doesn't look like it's quite a reflection of DEF. It doesn't look like it's going to be a translation either. So if you're a visual thinker, this will come natural to you, but if you're not, it's okay. It does take a little bit of training to be able to see this, okay? Triangle ABC will need to be rotated. The rotation will happen, and it looks like it's going to be a rotation of 90 degrees first. And then after the rotation of 90 degrees, it looks like that dotted triangle then is going to be shifted down. So the rule, okay, the sequence of rigid motion that will bring ABC onto DEF looks like it's going to be a rotation of 90 degrees counterclockwise. And then we're going to translate this 1 unit down. This is not the only approach to moving triangle ABC onto DEF. This is not the only sequence of rigid motions that will make this possible, but this is the way that I had approached it. So once again, we rotate 90 degrees counterclockwise, and we translate 1 unit down. This will map triangle ABC onto triangle DEF. See if you can pause the video and apply the concepts and skills utilized in that first example in this example here. So having gone through some thinking on your own, again, we're going to approach this through the use of some coordinate geometry proof. We are going to find out what the side lengths of AB is. AB is equal to 1. BC is equal to square root of 2, and AC is square root of 5. We can then also find out what is the length of DE, which is also 1. EF is square root of 5, and finally DF is equal to square root of 10. Thereby, looking at these two triangles, it looks like triangle ABC and DEF are not going to be congruent. So because they're not congruent, a sequence of rigid motions will not allow us to map ABC onto DEF. It wouldn't be possible. So again, since corresponding sides are not congruent, there cannot be a sequence of rigid motions to map the two triangles together. All right, so let's take a look at this example over here. Pause the video, see if you can figure this out. What we want to do, okay, with this, because this is not graphed on a coordinate grid, even though it's drawn on graph paper, it is not on a coordinate grid. So we're not going to approach this through coordinate geometry, but rather we're going to approach it as a statement and reason proof. So pause the video and see if you can prove the two triangles congruent, and then see if you can explain why or how we can bring triangle ABD onto triangle CFE. Okay, so hopefully you got some time to think about this. Okay, we're going to key in all the information that's needed in this problem here. So all the given information is right there. So we're going to draw all over this. We know that AB is congruent to FC. We also recognize that angle ABD, which is this angle over here, is congruent to FEC, which is this angle over here. Whoops, ADB I meant, so it's this guy. And lastly, ABD, which is this angle over here, is going to be congruent to FCE, which is this guy right there. So just based off of the givens, we already know that these two triangles are going to be congruent because of angle, angle, side. So yes, these two triangles are in fact congruent. Now, how are we going to map one triangle onto the other? Well, one way of thinking about this is, okay, we can actually perform a translation and then a reflection. So how do we put this into words? So the sequence of rigid motions include translating BD along BCDE so that BD and CE overlap. So I actually went this way. Okay? We're taking BD and we're pushing it down so that BD and CE will overlap. What we're going to do after that is we're going to reflect triangle ABD over line CE so that point A overlaps with F. Thereby, triangle ABD overlaps with triangle FCE. So we push it down and then we reflect. All right, last example. Let's take a look. So again, we're going to approach this through a statement and reason chart. Please pause the video and see if you can tackle this on your own, because this is very similar to the last example. So we're going to write all the given information down into the statement and reason chart. So that's what I have now. And what we want to do is we want to go through and prove all these things are true. We should mark down all the different side lengths that are going to be congruent and all the different angles that are going to be congruent. So as a result of this, okay, I immediately see, oh, that in step 4, I can immediately say triangle ABC must be congruent to triangle DEC because of angle, side, angle. All right, so, and actually that's it. Now, how are we going to describe a sequence of rigid motions to go from ABC to DEC? You're absolutely right. We need to perform a rotation. Now, a rotation of how many degrees? You do not need to specify for this, because this, even though this is graphed on a coordinate grid, even though this is graphed on, drawn on graph paper, it is not graphed on a coordinate grid. You will not be held responsible to describe what is the degree measure of rotation that you need to perform, but you just need to recognize that triangle ABC will need to be rotated so that A, B, C, and D, E, F will overlap one another. So the rigid motion include rotating points A and B clockwise over point C so that they land on points D and E. We're just rotating it in that manner there. And that's it.